connection. This connection, we have a force here. We have another force here. We have another force here. Maybe your force F1, 18 kb. F2, 15 kb. F3, whatever, to make your equilibrium, 50 kb. Anyway, then I will say, hey, design this connection, bolted connection. Maybe I will not give you any more information because you can assume what you want. Go ahead and decide, hey, I will use ordinary bolt. No, someone else. Hey, I will use group A bolt. The second one, hey, I will assume diameter of my bolt. Do you remember? Yeah. Diameter of my bolt 3/4. Someone else will say no, my diameter will be 7/8. So go ahead and assume, if not given, type of your bolt, diameter of your bolt, then I can tell you based on the type and the diameter what is the nominal strength of your bolt, Rn. So if you select your type group A and your diameter 3/4, then group A with threads in plane of shear, I will use this value, 54 A bolt. So 54 times your area bolt by divide 4, your diameter square. I can tell you what is the Rn. Multiply this value by 0.75, I can tell you what is the design strength of one bolt. Then, here, if you divide 18 divided by phi Rn, your design strength, I can give you how many bolts I need for this member. If you divide 50 divided by phi Rn, I can tell you how many bolts needed for this member. If you divide 15 divided phi Rn, I can tell you how many bolts needed for this member. You got it? Then, I will ask you to draw your connection. Do you remember how can I draw a connection? Yeah? First, your members will be drawn as a center line. Then, go ahead and draw your members. This member, this member, and this member. That's right. Go ahead and put your bolts. Maybe, for example, we need here 4 bolts. I need here 3 bolts. I need here 6 bolts. So 4 bolts, 1, 2, 3, 4. 1, 2, 3. But what is this distance is? Edge distance. Based on your diameter of your bolt, I can tell you what is the minimum edge distance. Okay? What is the distance between each bolt, center to center? 2 2/3 diameter, or most of the time we are using 3 diameter of your bolt. So I can tell you what is this dimension are. For 6 bolts, maybe I can put my bolt 6 or like this. That's fine. Then add edge distance here, edge distance, then close and draw your gusset plate something like this. There is your connection. Very easy. The most, or your question on bolted connection, how many bolts I need? How many bolts I need? And draw your connection. If you want to make check on bearing, that's fine. Check on bearing. This one, this value for bearing. This value for tearing. If you would like to make your safe for both of them, use the smallest value. Then multiply your value by phi. Your internal forces in each member must be smaller than or equal this value. You are safe. If not, you are unsafe. That's all. But mainly, I cannot do any check of bearing until you get your design. How many bolts, your layout, because your edge distance is very important to get your LC. This value. Do you remember? LC is the edge distance from the edge of your hole to the edge of your member. So I cannot get this value until you do your layout of your bolts. Last question is a very simple question. Do you have question?
Oh no.
No. Okay. Last one for welded connection. It's nothing, just one equation for design. Very good. This one. Your design, your nominal strength equal 0.707 W. Your weld size, L length time FNW. And if you would like to get your design strength, multiply this value by 0.75. To get your strength of the weld, this value will be 0.6 times something. Something based on what is the type of electrode rod you are using for welding. Then multiply this value and get your design strength. If you have longitudinal strength, longitudinal weld and transverse weld, I will do some calculation to get the greatest value between this one and this one, and I can tell you what is the design strength of this one. Something like this example. Your exam will not cover everything, but your project will cover everything. I did every condition, every case for your project, not for your exam. So I will try to make your exam more simple, but we need to do more calculation in your project. Any question? Any question? Okay.